Hello friends, welcome back to your favorite YouTube channel Snowpipe. I am Vaibhav, back with another exciting real-time end-to-end project on dynamic tables. In my last video, I have explained you about what are dynamic tables with their architecture and one hands-on lab. If you have not seen that video, I will recommend to you go and check that video first so you can get better understanding for this project. Friends, today's project topic will be very special for us because in today's project topic we are going to use one Java client for continuous streaming on our local device, and then we will going to stream that data using our Snowpipe streaming, and then after the streaming data will go to our base table, and then we are going to create three different types of dynamic tables, and we are also going to create two views, one secure view and one public view, and we are also using secure functions also. So stay tuned till the end of this video. This project will also beneficial for your resume building. If you add this project to your resume, it will be beneficial for your resume to get shortlisted for the position of data engineer, data scientist, and more data cloud platform jobs. So let's get started. But before going to start, friends, if you are new to this channel, hit the like button, share, and don't forget to subscribe so I can make more such content for you. So let's get started.
So friends, this is my GitHub repository and we are going to refer this repository for this project. So our project title is Snowpipe Streaming and Dynamic Tables for Real-Time Ingestion using CDC use cases. CDC means Change Data Capture. In today's project, we are going to implement a real-time database streaming and its transformation pipeline using Snowflake. The primary goal of this project is to simulate a change data capture CDC use case for stock market limit orders. We are going to capture a change data event of stock limit orders where changed and cancelled orders are captured and processed in real time. So this is our project overview and this is our project architecture diagram. So friends, we are going to use Snowflake Snowpipe streaming here for real-time data ingestion and dynamic tables for data transformation. We are going to use one Java client on our local desktop which will act as a mock database for simulating real-time data changes. We are also going to use one streaming agent which will capture change events. Then the Snowpipe stream data will be stored in our base table. This is our base table, all events landing table. Then we are going to create three different dynamic tables for different purposes. One is for the current limit orders. Second one is the SCD purpose. We are going to check the slowly changing dimensions of our dataset. Then third dynamic table will record only the summary of our dataset. We are also going to use three different schemas here. One is the ENG schema which will store the raw data, the base table, dynamic tables and views. Second one is the PII. PII means personally identifiable information, which will be encrypted, and only some roles have the permission to see that information. In the PII schema, we are going to use and create secure views and secure functions. Only some roles have the access to see that dataset. Okay. And we are also going to create one public view in public schema. So the use case for this project, friends, the source database we are going to use is containing stock trades of the Dow Jones Industrials, which is US stock market, with 200 million to 400 million stock trades which will executed per day. The streaming agent captures limit order transactions events for 30 US stocks. This streaming agent will capture the 30 US stock limit orders. Okay, and the goal is to provide 3 prospective on limit orders. Here, the current orders, then the history orders in slowly changing dimensions here, and the summary orders. We are going to organize the data in 3 different dynamic tables for current orders, historical data, and the summary of our orders. So let's get started, friends. For this project, we will require some prerequisites, the basic knowledge of our Snowflake and basic understanding of SQL. Then we will require a pre-installed Java and OpenSSL, because we are going to create an public key and private key for the encryption purpose in our local device. So we will require one Java and OpenSSL software installed in our local device. Okay. Then what we are going to build here, user and roles to control authentication and security. We are going to create 4 different roles in this project, friends, and each role having different access according to their role. A Snowflake database that contains all data and objects built in this lab. Okay, this table. We are going to create one database including this base table, which will contain all the streamed raw data. Then a landing table, yes, that landing table. Analytics ready dynamic table. Then secure functions for decrypting sensitive fields, then secure views to distribute data in various audiences. Right. Okay, friends. The second step is here. We are going to download this CDC Snowpipe streaming dynamic tables zip file. This is our Java client, which will stream the live data into our local device, and then the Snowpipe stream will be ingest the data into our base table. Then this is the SQL file which will contain all the codes required for this project. So I have downloaded the 2 files in my local device. As you can see here, simply I need to extract that files in my C drive. So simply extract this file in C drive. Okay. So as you can see, we have successfully extracted the file into C drive. Then the next step is this SQL statement file. So friends, I have already given you the code and uploaded the file here. So simply download this file from here and go to your Snowflake account. I need to log in my Snowflake account. Okay, then give your we have to create a new worksheet for this project. I have given name dynamic table project. Simply click here and import that SQL file from your local device. This SQL file is contain all the necessary code. And this okay. We are going to copy the code one by one because I'm getting some error. It's not getting the file. Okay, we have unzipped the our Java client, right? Then we have to use one code editor. I'm going to use Visual Studio Code for this project. So as you can see, I have opened the Java client folder here. Then simply open one terminal to run commands and simply copy this command, which will create public key and private key in your local device, which will be used to connect or configure our local device with your Snowflake account. So as you can see, our public key and private key has been generated. You can check it here. Yes, this is our public key. So simply copy it from here and store in your writer, notepad or somewhere else. Then what will be the next step? We are going to use roles. Create dedicated role and limited login for your streaming application. Return to Snowflake worksheet and run these commands using public key generated and file open in step 3 above. So simply copy these commands, paste it in your SQL worksheet. So friends, for this project, firstly we have to use account admin role. Then run these commands. We have created here this role for the streaming purpose. This role will have the permissions of the streaming data. Paste your public key in this code and run the code. So we have successfully configured our data. The next step is we have to edit the properties file. You will need to edit snowflake.properties file to match your Snowflake account name in two places. One is here and the second one is here. We have to paste our account identifier on these spots here. So go to your Snowflake first, copy your account identifier from here, then go to your code editor, open that file snowflake.properties and paste your account identifier here and simply remove this dot and use dash instead of. Same thing here. Paste your account identifier, remove dot and use dash and Control S. Save the file. The next step will be, so in this step, we have configured our Snowflake account to our local device. We are going to create new roles for this lab to and grant permissions. So simply copy this and run these commands. We are going to use account admin role. Then we are going to create EII admin role for the encrypted data purpose. Friends, you can check the detailed code in my GitHub repository. The next step will be create a dedicated virtual warehouse. We will require a warehouse, a compute engine, right? Then we are using an extra small warehouse for this project. Simply copy these commands and paste in your worksheet. Okay. Create your worksheet warehouse. Our warehouse has been created successfully and we are using it now. Then give permissions and privileges to both the roles. Okay, next step will be create database used throughout this lab. We have to create database to use for this project. I think I have already the database. Simply drop this. Yes, our database has been created and we will use that database and also we will give privileges to the role which we have already created earlier and we will revoke the permissions for our account admin role. Okay, the next step will be in all these steps we have to give privileges to our different created roles. Here we have created schema for our raw data, right? Which will contain the raw data, base table and dynamic tables. Next step is create a staging and landing table, our base table, where all incoming data will be landed initially and each row will contain a transaction. But JSON format will be stored as a variant data type within Snowflake. So we will simply create our landing table, our base table. Now our table has been created, but it doesn't have any data set or any table data. It is showing 0 count. Now in the next step, we are going to stream the data using our Snowpipe streaming, and we are going to ingest that data into our base table. So we have to run this test.bat file because we are using Windows local device, then we have to use bat file. If you are using a Linux or Ubuntu server, then you simply use test.sh file. So simply run /test.bat file. If you have connected your if you have configured your Snowflake account correctly, then it will show the results like this: successfully connected and test is complete. We have successfully connected our Snowflake account to your local device. Then we are going to run the streaming application using our Java client. You are now ready to stream data into Snowflake. Execute the streaming simulator using run_max.sh file, which will stream 10 lakh of records as fast as your desktop can run. Max will. Okay. So this is our file which will stream the 10 lakh of records data into our Snowflake base table. So simply run that file, this file, because we are using Windows. It will take some time as per your PC configuration. Yes. As you can see here, friends, 10 lakhs of rows has been sent to our local device. Sorry, from our local device to our base table using Snowpipe streaming, which we have already configured here. Successfully inserted 10 lakh of rows. Total time including 38 seconds. Okay. Simply go to your Snowflake worksheet and now run this command again. Yes. As you can see here, earlier it was showing 0 number of rows. Now it is showing 10 lakh of rows has been inserted into our base table. Now copy this command and check the data which we have inserted. Yes, as you can see, this is our limit orders of our US stock market data. So we have successfully inserted logs data into our base table. In this statement, we are going to check the order IDs using the primary key which have the token. Copy this select statement. As you can see here, this is our tokenized order IDs. Then order ID which I have encrypted means to client's name. We have encrypted those. Then action is inserted before and after. Before it was showing 0, then after we have all the data, including the price, quantity, client ID, and what is the position, long position or short position. Okay. Next step is, but there is more than one table in my source system, right? The CDC agent could easily be capturing changes from more than one source table, right? Let's prepare for that and write each dynamic table to only use events received for our simulated stock limit order stream. These are the key fields to use. Yes. The record content transaction schema in varchar. It's a production, and we have inserted the limit orders. Now the next step will be create dynamic tables. First, we will create dynamic table for the current state. Create one more finished dynamic table sourcing from landing table that reflects the current state, right, of our source table. This pattern for each source table, you create a dynamic table. Copy this command and run in your Snowflake worksheet. In this dynamic table, friends, I have already created my last video on dynamic tables. What are dynamic tables? What is their architecture? And one hands-on lab. So as you can see here, we are using lag time of 1 minute. In 1 minute, the table will be automatically refreshed with the fresh data, and score is 1 and action is delete. If click copy here and run the select star form statement to check the data of our current dynamic table. As you can see here, we have successfully inserted the limit orders in our current dynamic table. The count is 4,82,682 from our base table. Our base table have the data of 10 lakh rows, but we have organized the data and only inserted the limit orders in our current dynamic table. Okay, fine. Now we are going to stream data in not static data. Streaming data is not a static data. Let's work with dynamic data going forward. Return to your desktop to provide a continuous stream. Run this command and the application will be streaming in 10 records per second until you stop the application. In this step, friends, we are going to insert more data, more live data into our base table. We are going to check our streaming pipeline as well as our data from our base table to our dynamic table. So we have to run any one of these files which will contain the raw data, which will generate the raw data. So simply I will run dot S bat file. Sorry. As you can see, friends, our orders has been generating successfully. These are the new rows which we have been streaming. It will continuously streaming until you stop this using Control C. So let's stop it here. Yes. As you can see, we have inserted 1296 new rows in our base table, and then the dynamic table will get these rows after 1 minute time of 1 minute lag and refresh the new data with this 1296 rows. If you want to check, friends, simply go to your records here. As you can see, friends, here, earlier we have the data of 10 lakh rows only. Now it is having 10 lakh 1185 rows. So our data has been generated. And if you have seen this, we have increased the row number in our dynamic table. Then we are going to create slowly changing dimension SCD example, another dynamic table for SCD purpose. First table is created, but we want to analyze how orders records have changed and keep a historical record. Let's do that by adding additional fields to each record and to track and group them together. So copy the code and paste in your work. Friends, if you are getting any errors or any problems, simply comment down below. I will respond you as I can possible. Our second dynamic table has been created and it contains the total number of rows here. Let's check our SCD dynamic table. Sir. Yes. As you can see, friends, we are using the SCD table. Then that's why we have these columns valid from, valid to, and is latest and the version number. The current order which has active state is showing true and which have the dead state or deactivated stage is showing the false here. It is also showing the start date of the data and the end date of our data, and this is in current state. That's why it is from only having the valid from and doesn't have the valid to the exit time. Next, the third table will be aggregation and summary example table. Let's try some aggregations for dynamic table optimized for a specific use case. This table summarizes by stock and order type positions. Friends, if you are getting difficulties to understand these codes, simply pause this video or simply refer my GitHub repository. This is a very important and interesting project. So don't try to skip this project. It will be very beneficial for your resume. Now we are tracking the 30 Dow Jones Industrial Average stocks. Dow Jones is a US stock market name, both long and short limit orders. So we have created all 3 our dynamic tables for current order, SCD purpose and summary orders. So now we are going to check. In the summary table, we have the limit orders of only 60 rows. Now the next step will be monitoring dynamic tables. First, let's look at the properties page for a dynamic table. From the left side menu, navigate the databases create. Simply go here in your Snowflake account in databases. Refresh it. We have created this database in the ENG schema. As you can see here, our dynamic tables has been created. We can also check the refresh history, our target lag time, query run time here, and the graph also. Dynamic table have the advantage as we can check the graph here, as we have put the dynamic table on our base table. And we can check the refresh history also in our dynamic tables only. We cannot see it in our base table. The next step will be, as you can see here, we have checked this. We are going to monitor a landing table channels, specifically the offset token, identifying the source indicator of the last successfully committed row identifier. If there ever was an error on the source agent, this is the restart point on this. So we are going to see the channels. Of our base table. So as you can see, we have 3 different channels as we have inserted our row to our base table. Firstly, we have run the test command. Remember friends, then we have inserted the 10 lakh of rows. Then we have inserted the 1100 or 1200 amount of rows. As you can see here, 1185 rows here. It will give you the all details, including the table name, schema name, database name, and the name of your file and channel name. Next step is to deliver to consumers. This data is now ready for the public use. to create access for users to consume, let's use views to allow access, not JSON path syntax not seen or needed except from landing table. JSON syntax is not required except the landing table for our current view table. So we are going to create here views in our public schema. As you have know friends, public schema by default created when you create our database. So we don't have need to create separately the public schema. Our view has been created and we have given the permissions also to the public role. Handling the sensitive data, PII, personally identifiable information. This section will enable authorized users to utilize the order value, which was an encrypted at the source field, right? We have encrypted using the public key and private key. Next step will create roles assigned to authorized users. Now set up database for PII assets. Create PII schema and provide grants privileges to the PII roles. In this step, we are going to create new schema and secure views. In these steps, we are granting the permissions to our PII admin role and PII allowed role. Become PII admin. Right click on the house icon and open the new window. Now, further steps we have to generate on new worksheet. Simply use these commands, use PII admin rule, use schema, and use warehouse. Because we are using PII admin role, it is an only for the encrypted dataset purpose. The PII admin role have the access of our encrypted dataset. Other roles doesn't have the access. Reusable decryption secure functions. Need to have a function that can decrypt the value for consistency with the secure functions. Now we are going to create secure functions. Our secure function has been created successfully. We have given the name of decrypt AES. AES means Advanced Encryption Standard. So we are going to test then secure function using PII admin role. Yes, we have got the order ID. So our secure function is working properly. Then this pipeline decryption secure function. For simplicity of this lab, we will store the decryption key in a dedicated function. But ideally, this is stored in secret vaults. That's why we will create another secure function. Grant usage and test. same as earlier, we will give the privilege and then test the secure function. See, our secure function has been working. Okay, it's work. Access no longer needed. So we will revoke the usage privilege from our PII admin role. Now we are going to create a secure view. Earlier we have created the public view for the public view purpose. Now we are going to create secure view. Okay. Paste your commands here. Friends, use PII admin role here for this command and select the PII schema here and then run this command. So friends, I have given we are getting an error for the privilege section. In the privilege area, I have simply grant the privilege to account PII allowed to the create view. So now it's working. We can create the secure view in the PII allowed role. Now it can use the PII schema. Okay. Simply then run these commands. Next commands. Okay. Yes. One. UTC. You know. As you can see here, all the data updated. This is a secure view. What is the next step? Check security. Use role VHOL. Here's schema. Wow. So the eighth and final stage is to clean up. Use Control C to kill your streaming app running on your desktop. We have already done this step. See how many transactions you have been processed. We have already seen that, but let's do it once more. And these are our total number of rows. So this is the cleanup stage. We can simply clean up all this data if you want to. So friends, we have successfully covered setup KPI authentication into Snowflake, used Snowpipe streaming using Java API, and streamed data into Snowflake. We have use the Java client, and using Snowpipe streaming, we have streamed the data into our base table. Then we ingested the semi-structured data, means in this the data which is in JSON format. We have streamed it into a Snowflake in real time instead of bulk loading. Created multiple dynamic tables for data engineering tasks. Created secure sensitive fields beginning from the secure but also decrypted for those authorized. So friends, we have successfully completed our project on dynamic tables. Thank you and subscribe to my channel.